In this video, we will be discussing the law of sines. So we're going to use the law of sines when we're trying to solve oblique triangles. And an oblique triangle is just a triangle with no right angle. Now, the reason we need strategy to solve an oblique triangle is because, well, if we have a triangle that does have a right angle, what we can use is the regular trig ratios, and simply put, we could use Sohcahtoa to solve right triangles. However, if we have a triangle that is not a right triangle, in other words, it doesn't have a right angle, we need some strategies to be able to find all the sides and all the angles for that triangle. So that's where the law of sines comes in. So there are four instances or four cases that we're going to be looking at here. And all of these are the four cases of oblique triangle that we're going to be solving. Now, case one says when we have two angles and a known side. And then case two says when we have two sides and an angle that is opposite one of the given sides. So case one and case two we can handle with the law of sines. Case three and case four we need a different law, actually called the law of cosines, which we will look at in the video for 7.2. So in this video we're just going to be looking at these first two cases for the law of sines. Alright, so let's look and see what the law of sines actually is. So if we have a triangle, and again this is an oblique triangle because there's no right angles, and I labeled the triangle the angles and the sides. So remember, we label the angles with capital letters and we label the sides with lowercase letters, and if you'll notice, side A here is opposite angle A, side B is opposite angle B, and side C is opposite angle C. This will always be the case, and this is how you want to set up your triangle, where the sides and the angles have the same letters, just use the capital letter for the angle and the lowercase letter for the side. Alright, so here's where the law of sines comes from. What we do in the triangle is we draw an altitude from C, and this makes a right angle here. And what we notice is that we have a right triangle here on the left-hand side. Okay, and I have angle A down here. Now, if I want to find, let's see, the height of this altitude, what I can do is I can say, well, sine of angle A is equal to, well, the ratio of sine is opposite over hypotenuse. So the opposite side in this right triangle is h, the hypotenuse is b. And then I'm going to solve for h. So h is going to equal b times sine of a. And then what I can do on the right hand side of this triangle, oops, let's draw that better. So using this same altitude and this angle down here, angle B, I can say, well, sine B is equal to the opposite over hypotenuse. So the opposite side is h, the hypotenuse is a. So we could say is a sine of angle B is equal to h. Now what we see is that h is equal to b sine of a. H is also equal to a sine of b. So because these both equal h, I can set them equal to each other. So b sine a is equal to a sine b. And what I can do is, well, if I divide, divide both sides by ba, on the left-hand side, the b is going to cancel. On the right-hand side, the a will cancel. What we're left with is sine of a over side a is equal to sine of b over side b. And I could have gone through this process in a similar way to find a relationship between the side and angle of c. So this is also equal to sine of angle c over c. So this right here is the law of sines. right there. Okay. A similar way we could write the law of sines is if I take the reciprocal of all of these fractions, I could write this as a over sine of a is equal to side b over sine of angle b is equal to side c over sine of angle c. So both of these are equal, slightly different versions of the law of sines. Now going back to case 1, case 1 deals with solving triangles that are AAS or ASA. And what we mean by AAS is just angle, angle, side. And then ASA is just angle, side, angle. And this is just talking about what information is given to us. So if we're given two angles and a side, or an angle, a side, and an angle, and what this means is, well, angle, angle, side would be something like this. Where we have a triangle, we're given, let's say, angle A, angle B, and then we're given some side that is not in between those two angles. So maybe we're given side A over here, or maybe we're given side B over here. The second part of this, of case 1, angle, side, angle, well, if I have a triangle, now this is saying, well, I'm given two angles, but we have a side included in between those angles. So that would be angle, side, angle. So the first example says solve triangle ABC with angle A equal to 62 degrees, side C equal 14 feet, and angle B equal to 74 degrees. Round to the nearest tenth. Before we tackle this, let's just talk about what it means to solve a triangle. When we talk about solving a triangle, this just means find all sides and all angles. Alright, so what we're given is we have two angles here and we have one side. So there are 6 total values that we want to know when we're solving a triangle. In this question, we're given 3 of those values, 2 angles and a side. So what we need to find is that third angle and then the 2 remaining sides. Now, how I like to go about solving a triangle, I like to write out all the possible values and then fill in what I know, and so I know exactly what I'm looking for. So I'm looking for angle C and then side A and side B. So the first step that I take is just drawing a triangle, and then I'm going to label all the values that we know. So this angle A is 62 degrees, angle B is 74 degrees, and then angle, or side C is 14 feet here. Now, looking at this, well, we have 2 angles and a side. We have side C. So this tells us, well, looking at this, we have 2 angles and then the included side. The side is in between those 2 angles. So this tells us we have a triangle that is angle, side, angle. So the side here is in between the 2 angles. So this fits into case 1. And it's not imperative that you are able to identify that this is a triangle that is angle, side, angle, but it's useful to be able to categorize what type of triangle. So helpful, but not necessary. So first of all, we can figure out what angle C is, because all the angles in a triangle must add up to 180. So A plus B plus C must equal 180. C is 62 degrees, B is 74 degrees, so we need to find that missing angle C, and what is that, 136, so 44, C is going to equal 44 degrees, so I can put that here, and then I can go ahead and drop that into kind of my solution area. Okay, so found the missing angle. Now we need to find the 2 missing sides. This is when we use the law of sines. So to use the law of sines, we can use any 2 fractions in that proportion. So again, looking at the law of sines, I can set any of these 2 fractions equal to each other. Now what we have is, well, I have angle C and side C here. So I'm going to use that ratio. So I'll use this fraction, C and sine of C. So I'll say 14 feet over sine 44 degrees. And what I need to do is set that equal to a second fraction, and that second fraction will have a missing value. So I'm going to try and solve for side B here. So side B over sine of angle B, which is 74 degrees. And then from there, we just need to multiply both sides by sine of 74 to get that to cancel. So we end up with 14 times sine 74 over sine 44, and that's going to equal side B. So you just type this into your calculator, make sure you're in degree mode because our angles are given in degrees. And typing that in and rounding, I get 19.4 feet. So 19.4 here. And then I'm going to do or follow the same procedure to find side A. Again, I can use any two of the fractions from the law of sines, set those equal to each other. And what we want to do is, because we're looking for side A, I'm going to put that in the numerator. You don't need to put the missing value in one of the numerators, but I found it requires us to take one less step when we're solving. And then what I always like to do is use the given ratio, because if I use the b's here, while it would work, maybe I made a mistake in this first calculation, so I want to use what I know to be true. So side C is 14 feet over sine of 44. Multiply both sides by sine of 62. We're going to get A is equal to 14 sine 62 over sine 44. So we get A to be equal to 17.8 feet after rounding. So this is 17.8 feet. And so we have solved the triangle because we have found all the missing sides and missing angles. Now, one thing to check for is we want to make sure that whatever angle is the biggest, that must be opposite the largest side. So in this case, 74 degrees is opposite 19.4. Those are both the largest values, so that's good. The smallest value must be opposite the smallest value. So the smallest angle and the shortest side are opposites, and then whichever values are in the middle, those need to line up. So now, while this isn't a guarantee check that ensures that the values you found are correct, this is something to look for, because if we have, for example, the largest angle opposite the smallest side, we know something is wrong. So we need to go back and recalculate. Let's check out this next example. It says, from a point on a level plane at the foot of a mountain, a surveyor finds the angle of elevation to the peak of the mountain to be 20 degrees. She walks 3,465 meters closer on a direct line between the first base and the base of the mountain, and finds the angle of elevation to be 23 degrees. Estimate the height of the mountain to the nearest meter. So what we're trying to find is this distance right here. And what we notice is that this triangle is a right triangle. Now we know how to find the values in a right triangle. We can use Sohcahtoa here. However, in this right triangle, we only know this angle, 23 degrees, and we know the right angle. We would also be able to find this angle up here. However, we need one of these sides to be able to use Sohcahtoa. So what we need to do is, well, we're going to use this little triangle over here to find one of the sides, namely side A here, because if we can find side A, that then is the hypotenuse of this right triangle. So what we'll do is use the law of sines, find side A, and then that A is a length for both of these triangles, so we can use it in the right triangle, and then ultimately find the height. Alright, so looking at this triangle here, that's triangle ABC. And what do we have? We have angle A is 20 degrees, we have angle B is 157 degrees, and then we have 3 degrees for angle C. Now what do we know? We don't know side A, we don't know side B, but this down here, that's 3,465 meters, that is side C, so 3,465. So what we want to do is we want to find side A here. So what I can do is I can use these two values and these two values in the law of sines. So again, we're looking for side A, so put that in the numerator, divided by sine of 20 degrees. That is equal to 3,465 divided by sine of 3 degrees. Remember, when you're setting this up, we need to either put, we just need to line up like values in this proportion. So the sides are both in the numerator, and then the angles are both in the denominator. Remember, we can take the reciprocal as long as we take the reciprocal of both sides. So solving here, I'm going to multiply both sides by sine of 20. So that cancels. We're left with A is equal to 3,465 sine of 20 degrees divided by sine of 3 degrees. And entering that into the calculator, we get an A value that is 22,644, let's call it 0.1, and the unit here is meters. Alright, so we figured out this side A here, 22,644.1 meters. Okay, now we have a right triangle, and I have this angle down here. We're looking for the height, and we know the hypotenuse. So what ratio takes into account? And from this angle, we have an opposite side and the hypotenuse. So that's going to be the sine ratio. So we'll use sine of 23 degrees is equal to opposite, which is the height, divided by the hypotenuse. Whoops, opposite is O. So we have the opposite side. Well, this is, I do want to put an H there because that's the height. So this is the opposite side. So we want the opposite side divided by the hypotenuse, which is 22,644.1. So multiply both sides by 22,644.1. Sine 23 degrees, and that will give us the height. And typing that into the calculator, I get 8,847.7, so 48 meters is the height. So just to recap, we first used the law of sines over here to find that missing value for side A, and then we noticed that we have a right triangle. That triangle CDB is a right triangle. So because we have a right triangle, we can use sine of angle B is equal to opposite over the hypotenuse. Now, case 2 that we will apply the law of sines to is the side-side angle case. Now, this is sometimes called the ambiguous case because when we're given two sides and an angle that is not included between the two sides, this could lead to a few separate situations. As you can see in this image, we could have no triangle, we could be given one triangle, or this could lead to two triangles. Now, let's just kind of summarize what's happening here. In this first triangle here, we're given an angle, we're given this side, and then this opposite side, or the angle that's opposite side, or sorry, this side that's opposite side angle, this side is too short to reach down here to create a triangle. So that's why we have no triangles possible with those given values. In this second triangle, we're given this angle on this side, and then what we see is this side actually forms a right triangle. So because that forms a right triangle, we can use the law of sines to solve that triangle. However, if we realize that it's a right triangle, we could simply use Sohcahtoa there. Two triangles, this is the one that's probably the most challenging to see. So if we're given, again, angle A, side B, if we're given a length for side A such that we can have side A drop down to form that triangle. However, what we can also see is that side A could swing out here and connect at this point B2. So then we would have this second triangle, the second big triangle here. So that's where we get those two triangles from. Now, what you'll see, and we can kind of walk through in a similar fashion to the rest of these triangles. Now, what we'll see is that when we have a situation side-side angle, we're just going to solve this as we regularly would when using the law of sines. And what we'll notice is that how we calculate will show us whether we have no triangles, one triangle, or two triangles. Alright, let's check out this example. It says how many triangles can be drawn with these given values: angle B, side C. So let's go ahead and draw what we have here. So I have angle B down here. Let's call this angle C, and then somewhere over here we're going to have angle A. Now, so side C, let's see, how do I want to label this? Angle B is this 41 degrees. Side B is going to be over here. Let's call that 3.3. And then side C, my colors are getting a little confused here, 5.4. Now, I'm just using dotted lines because I don't actually know where side B is going to be. It could be as I've drawn it. Side B could be coming back in kind of slanted to the left. So I'm just using dotted lines here because I don't precisely know what this triangle looks like. Alright, but looking over here at the table that I've drawn, we do have an angle and a side that correspond to each other. And then what I can do is I have side C, so we can calculate angle C. Now, because we're looking for an angle, I'm going to put that angle in the numerator. And actually that's going to be sine of angle C divided by 5.4. That is going to equal sine of 41 degrees divided by 3.3. Alright, so we need to solve for angle C here. What I'm going to do, multiply both sides by 5.4. We get sine of C is equal to 5.4 sine of 41 degrees divided by 3.3. Now I'm going to calculate the right-hand side first. I get sine of angle C is equal to 1.07. At this point, what we would do is to calculate this, we would use a calculator and we would use the inverse button on the calculator. And this is how we would type it in. Sine inverse of 1.07 is equal to angle C. Now, if you type this into your calculator, you're going to get something that says error, or maybe it'll say undefined. Okay, now why does it say this? Well, what this is saying is sine inverse of 1.07. What that means is what angle has a sine value of 1.07. Now if you think of this on the unit circle, where does sine equal 1.07? It doesn't equal 1.07 anywhere. The largest value for sine we ever get is 1. Because we get this error message, this tells us that there is no possible triangles that can be created. So the solution here we would say is no possible triangle. Okay, so anytime we get this error message, that tells us no triangles are possible. And one last thing to mention here. Well, what is actually happening? Well, we have this triangle, or we have these given values. We know that angle B is 41 degrees. We know that side B is 3.3 and side C is 5.4. So 5.4 is down here. And that side B, well, if I were to draw that with 3.3, well, that distance right here is not long enough to reach this point down here. So 3.3 is too short to actually create a triangle. And no matter where it goes, I can't swing it down to have it hit at the end of this value, this length of C at that point. So that's actually what's happening. Now for this actually to create a triangle, we would need the 3.3 to be longer to make up for this distance right here. Okay, one more that's similar to that last one. How many triangles can be drawn with A equal to 42 degrees, B 2.4, and A equal to 2.1? All right, again, this is going to be side-side angle here. We can go ahead. This is going to be 42 degrees for angle A. Say that's A. B is up here. We don't know angle B, but side B will be over here, 2.4. And then side A, 2.1. Now again, does that side A reach down here? Or is it too short? Or does it reach here and over here to make two triangles? So that's what we're going to try to figure out. Alright, so what we have is we have an angle and a side that are opposite each other. Then we're going to try and find angle B here. So because we're looking for angle B, I'm going to put that in the numerator. That's equal to sine 42 over 2.1. Multiply both sides by 2.4, I get sine of B is equal to 2.4 sine 42 divided by 2.1. Calculating the right-hand side, we get sine of B is equal to 0.7647. So we need to use the inverse function here. Sine inverse of 0.7647 is equal to angle B. And typing that in, we're going to get an angle B that is equal to 49, let's call it 0.9 degrees. Alright, but we need to really think about what this means. What this is saying is, what angle has a sine value that is 0.7647? Now if we look on the unit circle, where is sine positive? Sine is positive in the first quadrant. It's also positive in the second quadrant. And what we found was this 49.9 degrees corresponds to what's in the first quadrant. Now, we need to consider what is happening in the second quadrant. So to figure out this value right here in the second quadrant, well, this reference angle in the first quadrant is 49.9. That is equal to this reference angle. So this down here is 49.9 as well. So what this angle is 180 minus 49.9. And typing that into the calculator, we get 130.1. So what this is saying is there's two possible angles. We could have this little angle here that's 49.8 degrees, or it's also possible that we could have this big angle that is 130.1 degrees. So let's see what happens. We figured out 49.9 degrees, and that should tell us what angle C is. And angle C, well, all of the angles add up to 180, so if I add 42 plus 49.9, and then subtract that from 180, what we're left with is 88.1 degrees. So those three angles add up to 180. That would create the first triangle. Now, it appears that we have a second angle that would create a second triangle here. So I'm going to write out the table of values again. And I just filled in what is known. Now, it looks like this 130.1 could also, not angle B, but angle, angle B. It looks like that 130.1 could also be a different value for angle B. So 130.1. And then what happens when we add 130.1 plus 42? We get 172.1 minus 180, 7.9 about. So that would make the other setup for this second triangle. Now what we want to look for is, well, let's back way up. When we're at this point down here, when we type in the inverse, we need to consider both possible angles. For sine, because this is going to be positive, we're always going to find an angle in the first quadrant and the second quadrant. Once we calculate those two angles, angle in the first quadrant was 49.9 degrees, angle in the second quadrant was 130.1. Once we find those two possibilities, we need to check in our solution over here and over here. So 49.9, what happened was when I added angle A and angle B together, that did not exceed 180 degrees. So there is a possibility for angle C of 88.1 degrees. Similarly, when I look at using 130.1 degrees with 42, when I add those together, those do not exceed 180 degrees. Now if those exceeded 180 degrees, there would be nothing left over for angle C. If there's nothing left over for angle C, that means that this situation over here would not create a second triangle. We would be stuck with just one triangle. However, because these two angles do not exceed 180 degrees, there's something left over for angle C to be. So we've answered this question. It's just asking us how many triangles can be created, and the solution, there are two triangles that can be created with the given information. This next example now asks us to solve the triangle. So we're given an angle and two sides here. So we don't have angle A, don't have angle B. We do have angle C, that's 40 degrees. We have side A, which is 15 meters. We don't have side B, we do have side C. Alright, so this is a side-side angle situation. So this is the ambiguous case. Setting up, we're going to try to solve for angle A first. So sine of A is equal to sine A over 15 is equal to sine of 40 degrees divided by 20. So multiply both sides by 15, I get sine of A is equal to 15 sine of 40 degrees divided by 20. We get sine A is equal to, punching that in, 0.4821 about, 0.4821. So to find this angle A, we're going to use the inverse, sine inverse of 0.4821, and that is equal to A. So we get an A value. We get A is equal to, let's punch that in, sine inverse. I got about 28.8. So angle A is 28.8 degrees. Okay, so I know that this is going to go right there. Now let's consider this. Remember, when we take the inverse, we must consider both possibilities. So both possible angles, what this is saying over here is what angle has a sine value of 0.4821? So sine takes on a positive value of 0.4821 in quadrant 1, quadrant 2. Quadrant 1 is going to be that 28.8 degrees. So what is the corresponding value in quadrant 2? Well, the reference angles are the same, so that reference angle in quadrant 2 is 28.8. So we're going to say is 180 minus 28.8, and that gives us 151.2. Okay, now it would appear that, oh, we're going to have two triangles. But if I plug in 151.2, let's see, if A is equal to 151.2, and we already know the angle C is 40 degrees, well, if I add 141.2 and 40 degrees together, that's 191.2 degrees. What that tells us is there's nothing left here for angle B because 191.2 is over 180 degrees. So this tells us there's only one possible triangle. Alright, so this is kind of talking more in depth about what this means when we say the ambiguous case. The key point here is anytime we use the inverse, if you type in the inverse on your calculator, you must go through this exercise of figuring out, well, what are those possible angles? And then once you figure out those two possible angles, you must put them in your solution to see if those possible angles, if both possible angles actually work. The first one, the one in quadrant 1, that will always work. The angle from quadrant 2 may or may not work, so you must double check that. Alright, so to find angle B, well, I just add 40 plus 28.8 together, and then subtract from 180, and we're left with 111.2 degrees. Okay, and so now to find side B, I just use the law of sine. So side B over sine of 111.2 degrees, and then I can use either pair for that second fraction. Again, I like to use what's given to us, so this will be 20 meters over sine of 40 degrees. So B is going to equal 20 times sine of 111.2 degrees divided by sine of 40 degrees. Punching that into the calculator, we end up with 29.0087, so rounding to the nearest tenth here, we'll just have 29.0 meters, so 29.0, so that is our missing value here. And there we have it. So we've solved this triangle. Alright, one more similar example. We're given angle B, side A, side B. So let's go ahead and find angle A. We're going to say sine of angle A. Again, whatever is unknown, let's put that in the numerator. Divided by 8.3 inches is equal to sine 56.3 degrees divided by 7.6 inches. Multiply both sides by 8.3. We get sine of A is equal to 8.3 sine 56.3 degrees divided by 7.6. We get sine A here equal to, I don't have that on my paper. I got a value of 0.9086. So sine inverse of 0.9086, we get a value of A that is equal to 65.3 degrees. Okay, so we know that A could be 65.3 degrees. What I mean is we know that this is definitely one of the possibilities for the triangle. What we need to check is there a second possible triangle? So again, sine is positive in quadrant 1 and quadrant 2. We have 65.3 degrees here. That is this reference angle. So in quadrant 2, that reference angle is also 65.3. So to figure out that angle, we're going to do 180 minus 65.3. And I get 114.7. Alright, so we have two angles. We know 65.3 is going to work because if I add 65.3 and 56.3, I don't get something that is greater than 180. What do I get? 111.6, I think. Let's just do that. Plus 56.3. 121.6 rather. So subtract that from 180. Now what's left over here, we have 58.4 degrees. So there is enough left over before we get to 180 to make up that angle C. Now if I add 56.3 plus 114.7, we get 171. So that is not greater than 180. So what that tells us is there are 9 degrees left over for angle C. So what this tells us is there are two possible triangles. Alright, so what we need to do is just set up a second table here with all the values, and that'll allow us to fill in everything for that second triangle. I filled in the given values. We found angle A to be 114.7. And what's left over is 9 degrees, so angle C is going to be 9 degrees. Now what we need to do is we need to find side C in each of these triangles. So I'll go ahead and do that. Alright, so I use the law of sines to find side C for each possible triangle. So what we've done is we've solved both possible triangles here. Alright, one last example here. It says a laser beam with an angle of elevation of 42 degrees is reflected by a target, which the target here is this helicopter, and is received 1,200 yards from the point of origin. Assume the trajectory of the beam forms an isosceles triangle. So that just means that this side and this side are going to be equal to each other. Find the total distance the beam travels around to the nearest yard. What is the height of the target around to the nearest yard? Okay, so what we see here is we have a triangle. Because we have a triangle, all the angles add up to 180. So we know that this angle up here is 96 degrees. And what are we trying to find? Part A says find the total distance the beam travels. So what we're going to do is we're going to find, let's label some of these things. So there's our sides. So because side A is over there, that means angle A is here, angle B, and angle C is up here. Alright, so we need to find side A and side B. Now what we can do is, because this is an isosceles triangle, I'm going to use the law of sines here to find, how about side A. So looking for side A, I'm going to say A divided by sine 42 degrees. Right, side A and angle A go together. And then I also know C. So side C is 1,200 yards divided by sine of angle C, which is 96 degrees. Multiplying both sides by sine of 42, I get A equals 1,200 sine 42 degrees divided by sine 96 degrees. And doing so, I'm going to get I get about 807 yards. 807.379, let's call it. Now looking at this, because I did not take the inverse sine function, this is the only possible length. There's not a possibility that I would have two different triangles here. Remember, if we take the inverse in these questions, that's when we need to check for multiple angles. Because I'm not taking the inverse here, this is the only possibility. So side A is going to be 807 yards. Well, that means side B is also 807 yards because this is an isosceles triangle. Both of those lengths are the same. So the total distance the beam travels is going to be 807 plus 807. So I get 1,614 yards. So that would be the solution for part A. Then it says, what is the height of the target? Round to the nearest yard. So the height of the target is just this. At this point, I see on this triangle on the left here is a right triangle. So because that's a right triangle, I have this angle down here. I have the hypotenuse, which is 807. I can use that to find the opposite side. So this is going to be Sohcahtoa with sine. Sine of 42 degrees is equal to the opposite, which in this case is called the height, divided by the hypotenuse, which is 807. So 807 sine of 42 is equal to the height. So punching that in, 807 sine 42, I get about 539.988, which rounding that to the nearest yard is 540 yards. There we have it.